Okay, question 12. Express root 2 over root 40 as a fraction with a rational denominator. So right now we've got a rational denominator because we've got a surd on the bottom. So we need to undo the surd. We need to have a nice integer on the bottom. Okay, so there's two different ways you could do this. I think the easiest way is to always just say, okay, so I've got root 2 over root 40. And I would just times the top and the bottom by root 40. Okay, so because we're timesing the top and the bottom by the same number, that's allowed. We can just times the top or the bottom. What we do to the top, we have to do to the bottom. Okay, so that's fine because we're effectively just timesing it by 1. Okay, but it's going to make it a much nicer number, a much nicer equation. Okay, so that's going to give us root 2, root 40. And root 40 times root 40 is going to give us 40. Okay, so that's us solved the rational denominator part because we've got rid. That's how I've got rid of the surd. I've times it by itself. I've effectively squared it because I've done root 40 times root 40. So I've squared root 40. So I've got the square root of 40 squared, which is just 40. Okay, so I've done that bit, but now we need to simplify. Okay, so here's our first rule. Root 2 times root 40, that's the same as root 80. Okay, so we can keep the surd sign and multiply the two numbers inside. Okay, so that's rule, the multiplication rule for surds. Okay, so we're getting close, we're getting there. But I think we can get root 80 down to something a wee bit more manageable. Okay, so now we can maybe think about breaking that up into something. So why don't we try, let's do root 4, root 20. Okay, so if we say we've got root 4, root 20 divided by 40. I know that root 4 is going to give us 2, and again, sometimes it might help on the side. You could just write down some of your square numbers, okay, just to help you remember. So if 2 squared is going to give me 4, then root 4 is going to give me 2, okay. 3 squared is going to give me 9, so root 9 will give me 3, okay. You could write them just to the side, root 16, etc., okay. That might help. So root 4 and root 20, so I know that's going to give me 2 root 20 divided by 40. And 2 over 40, I know that's going to give me 1 over 20. Yeah, so I'm dividing this by 2 and this by 2. So if I divide both these by 2, that becomes 1, and that becomes 20. So right away we're thinking, oh, this is looking sensible. This is going to start to simplify, root 20 over 20. Okay, so root 20, what can we break that up into? Root 4, root 5. Okay, so just thinking about your factors, what numbers are you have 20 and 1, 10 and 2, 4 and 5. So again, that was quite nice to me. That's going to give me 2 root 5 over 20. And again, 2 and 20 divided them both by 2 is going to give me root 5 divided by 10. Okay, I think that's as far as we could take that. Okay, so that's one way of doing it. For your marks for this, you'd be looking to get a mark for this step, so knowing to multiply to get rid of your denominator. And then I think by the time you get to about here, you're getting another mark, and then one on the end as well. Okay. The other way of doing it, you could start to break up the bottom. So the way I kind of multiply through here, okay, let's get rid of this. You could just start to break up the root 40, okay. So what if we said, let's just keep the root 2 where it is, and say, right, well, instead of root 40, why don't we call that, we could do root 2, couldn't we, root 2, root 20. Okay, so then they cancel out. So now we've got 1 over root 20. When you take that further again, we could say 1 over root 4 root 5, which is 1 over 2 root 5. And then we just have to times the top and bottom by root 5 to get rid of that. Times by root 5, times by root 5. So we're left with root 5 over 2 times 5, which is 10. Yeah? So, that's another way of doing it. It's just about trying to simplify these things down, and all you're thinking there is factors. There's nothing particularly complicated about it. It really is just thinking about your factors. Okay? So, I'll leave that on there for next time I work. Okay? So yeah, the important thing here, rational denominator, so you don't want a root on the bottom. To get rid of it, simplify it through the way I did here, or always remember, just times the top and bottom by this number. Okay? And then that'll give you a nice number on the bottom, and then you're simplifying as far as you can go. Okay? So you're trying to get down to your the smallest possible number. Okay? Good stuff. On to the next one. Cost graphs. Okay. So when you see graphs like this again, think about questions like this, think of the relevant information. So there's your equation. You got a 2-mark question and you want the coordinates of A. Okay? So again, I always think the easiest thing with these graphs is this number, the vertical number, the 3. Okay? So that number dictates the height of the graph. Okay? So if that's a 3, that's a 3, and that's minus 3. Okay? That's going to be the height of the graph above the x-axis. Okay? So, right away, I'm thinking, well, for a coordinate, I know what my y is, and that's going to be minus 3. So right away you've got a mark. And that is very easy. So you get half marks on a trig question. So if you're thinking I'm struggling with maths, that's surely an easy get. Okay? The s-coordinates are a little bit trickier, but still we can have a good guess even if we're not totally sure. So again with these I would always try and draw out, what do I know? Okay? Now we should all know our cost graph, okay? That is quite a bad cost graph, but we'll take it, okay? Now this point here right in the middle happens at 180 because we know the period of these graphs is 360, okay? So if this hadn't been changed, we would say that was 180. But it's been shifted, hasn't it? And it's been shifted in this direction. So 180 is actually over here somewhere, isn't it? Because we've moved our graph over. Okay, now how much have we moved it over by? 45. Okay, so that is going to be 180 minus 45. So that's going to be 135. Okay, the graph is over here somewhere. Yeah, that should have been over there. Okay, so the whole thing's been shifted. Every point has been moved to the left. Okay, and again, if you wanted to check, if you were guessing and you weren't sure if it was plus or minus, okay, first of all, I think it looks sensible, okay, because you can see physically it's moved over that way, okay. But also, let's just work it out, okay. So if we substitute these numbers back into our equation, so y is going to be minus 3. So at the point we're looking at, we're saying minus 3 is equal to 3 cos of what? So if we said that's 135, so x represents 135 plus 45 gives us 180, okay. Now, cos of 180, we know gives us minus 1. So minus 3 times minus 1. Yeah? Not times, sorry, equals. So minus 3 equals 3 times cos of 180, which is minus 1. So minus 3 is equal to minus 3. Okay, so we can actually prove that what we've got in there is correct. Okay, so yeah, when you get these questions, feel free to have a guess. The 3 should be very easy, and you can actually just double check that, but you should know the rules. If there's a plus sign in there, we're moving the graph to the left. Okay.